This is a video for the test 4 review, and the test 4 review, let's go back to the things that we need to know. So to be ready for this test, you are going to need to make sure that you know all of your trig derivatives, all 6 of your trig derivatives, inside out, backwards, and forwards. You're going to need to be able to recognize and apply the product and the quotient rules. You're going to need to be able to use your math eyes to know when and how to apply the chain rule. And to be quite honest, this test, it really is a math eyes test. You're going to need to know the derivative of e to the u, ln of u, and a to the u. You're going to need to be able to deal with logarithmic differentiation, symbolic derivatives, implicit differentiation, understanding the how to write the equation of a tangent line, what a normal line is and how to write the equation, how to find vertical and horizontal asymptotes. No, that's supposed to actually say tangents, vertical and horizontal tangents, not asymptotes. Interesting. And how to find second derivatives. So this test is really packed full of stuff, so don't take it lightly, take it seriously. In your packet, you have done a sheet called I Gotta Learn This Stuff. It's a really important sheet. It has a lot of information. It has a lot of practice of the chain rule, and it gives you a good practice for math eyes. So let's jump into the review, which is in your packet, and begin with problem number 1. So as I said before, remember that this is a test of your math eyes. So when you look at problem number 1, what is it that you spy? Hopefully you see that we have a tangent as an outside function and an angle measurement as an inside function. Students often forget the angle measurement. So this is going to need the chain rule. So y prime, 3 is the coefficient, and then I'm going to take the derivative of tangent, which is secant squared of the angle, and then you have to remember to multiply. The inside function is the angle, so you have to multiply by the derivative of the inside function, which is 4. So 3 times 4 is 12. That can be multiplied. Secant squared of 4x is your answer. In problem number 2, we're going to use our math eyes. So be careful right here where you see the x to the 5th power. That is cosecant of x to the 5th power. The 5th power is not on the cosecant. So the outside function is cosecant. The inside function is the angle measurement. So the derivative of cosecant, when you're working on this thing, it's a so the derivative is negative, and the derivative of cosecant is negative cosecant of the angle, cotangent of the angle, and you can put those in parentheses if you want to, multiplied by the inside, which is the derivative of the angle. So I would rewrite that as, I would put the 5x to the 4th in front and make that negative 5x to the 4th, cosecant of the angle, cotangent of the angle, and that would be my final answer for number 3. All right, I'm going to clear those annotations. In problem number 3, your math eyes need to notice that there is a product of 4x squared and e to the 3x. So I'm going to come over here. My first factor is negative 4x squared, and my second factor is e to the power, or e to the 3x. The derivative of negative 4x squared is negative 8x. The derivative of e to a power is e to that power times the derivative of the power, and the derivative of 3x is 3. Now we're dealing with the product rule, so we are going to multiply these two, multiply these two, and we're going to add plus and product. So we end up with negative 3 times 4 is 12, x squared, e to the 3x, and the order of those, either x squared or e to the 3x, doesn't matter. It's multiplication, which is commutative. And then we're going to multiply negative 8x times e to the 3x, so negative 8 e x, ex to the 3x. Problem 3. Problem number 4. Now we have compared 2 to 4. Here the power of 5 is only on the x, but here the power of 2 is on the whole thing. So this is the same thing, and it's very helpful to rewrite this with the power on the outside. The next important thing is to recognize that we have the power rule as the first link of the chain, the trig as the second link of the chain, and the angle is the third link of the chain. Don't forget the angle. So y prime by the power rule, I'll have 2, leave the inside alone, sine of 3x, technically to the first power. I'm just writing that for emphasis. That takes care of number 1. Number 2, I have to take the derivative of sine of the angle, which is cosine of the angle. That right there takes care of number 2. And then the third link of the chain is to multiply by the derivative of the most inside function, which is the angle of 3. So that can be rewritten as 6 sine 3x cosine 3x. Be careful with the trig. Number 5, we have e to a power, but that power happens to be a product. So make sure your math eyes see the product. So we know that the derivative of e to a power, if we have e to a power, the derivative is e to the power times the derivative of the power. So down here, g prime, change colors, g prime of x is going to be e to the power times the derivative of the power. So now I'm going to perform the product rule. So my first factor is negative x. My second factor is secant x. The derivative of negative x is negative 1. And the derivative of secant x is secant x tangent x. So we're going to multiply and add. So that would give me negative, whoa, change colors, negative x secant x tangent x minus secant x. Could I factor out a secant x? I could. Does it help me? Not really. So that's e to the power times the derivative of the power, and I would basically leave that just like that. In number 6, when I use my math eyes, I hopefully see ln of something. The derivative of ln is u prime over u. In this case, the inside function of u is cotangent x, and u prime, the derivative of a co, is negative, so negative cosecant squared x. So if I do u prime over u, I will get y prime, and u prime is negative cosecant squared x over u, which is cotangent x. And there's probably some trigonometry we could play with there to rewrite that if we were to change everything into sines and cosines. I would honestly take this as an answer on the test, and you don't really have to play with that trigonometry, even though it's fun. All right, let me clear the screen again. And let's go to arrow down. Come on, you give me more paper. All right, number 7, math eyes. When I look at number 7, I hope that you are seeing a to the u, an exponential function, where a is 4 and u is 5x squared. So the derivative of a to the u is keep the function, a to the u, so there's keeping the function, times the ln of the base, and the base is 4, times the derivative of the power, which is 10x, and you cannot multiply the 4 right here times the 10 right here. Nothing is going to multiply together. That is your final answer. The order of these 3 factors doesn't really matter, but that's your answer. Number 8 looks like a symbolic derivative. We have a given point on f, 1, 2. We have the derivative, and then we have this function named g of x, and we're finding the derivative of g. So when we find the derivative of g of x, I'm going to do that with variables first. G prime of x, I have an outside power operating on f of x, so I need the chain rule. So I'll have negative 3, leave the inside alone, so f of x just comes along for the ride. Decrease the power by 1 to negative 4. That's the derivative of the outside, and then multiply by the derivative of the inside. Now I can substitute the 1, and that'll give me negative 3 times f of 1 to the negative 4 power times f prime of 1. Be careful in grabbing these values. I often make mistakes here. So f of 1 is 2, so I have, whoops, see, I already made a mistake. Eraser, there we go. So I have negative 3 times, as I said, f of 1 is 2 to the negative 4 power times f prime of 1 is 4. Watch carefully with the algebra. That's negative 3 over 2 to the 4th power times 4. Only the 2 has a power of negative 4. That's the same thing as negative 3 over 16 times 4, because 2 to the 4th is 16. And 4 divides into 16 4 times, and that gives me a final answer of 3/4. Be careful in cleaning up your fractions. And then number 9. In number 9, I am finding the derivative at a particular value of x, and so using my math eyes, I see cosecant cubed of 2 theta, which is the same thing as cosine, I said cosecant, I'm sorry, cosine of 2 theta cubed. So I have, number 1, I have to take care of the power. Number 2, I have to take care of the trig. And number 3, don't forget the angle. So when I find the derivative, f prime of theta, power rule, 3 quantity, to the 2nd power, decrease the power by 1. The derivative of cosine is negative sine 2 theta times the derivative of the angle. Don't forget to take the derivative of the angle. I'm going to clean that up a little bit before I substitute. So 3 times 2 times the negative is negative 6 cosine squared 2 theta sine 2 theta. All right, that's my cleanup. And I'm substituting pi over 12. So over here on the left, 2 times pi over 12, to simplify that, is pi over 6. Nice, a special angle. So f prime of pi over 12 is negative 6 times, I've already multiplied 2 times pi over 12 to be pi over 6, so that's cosine pi over 6 squared, important to know where the square goes, times sine, 2 times pi over 12 is still pi over 6. We know that pi over 6 is the same thing as 30 degrees. We know that the cosine of 30 degrees is root 3 over 2. 1/2 are the coordinates for cosine and sine. So that's going to give me negative 6. Cosine is the x value of pi over 6. That's root 3 over 2 squared. Sine of pi over 6 is 1/2. So that's negative 6 times 3 over 4, square the numerator and denominator, times 1/2. 2 divides into 6 3 times, and then 3 times 3 is 9, so that's negative 9 over 4, if I didn't make any mistakes. Hopefully I did not. 2 times pi over 12 is pi over 6. Pi over 6 is 30. Root 3 over 2 is the cosine. Just checking. Hopefully I'm checking and not just making the same mistake over again. I squared the numerator, denominator. Looks good. All right, and then number 10. Looks like I'm looking at a point-specific. In problem number 10, it looks like we're looking at a definition of derivative by the limit process. So it appears to me that we are looking at, let me get a color you can see, it looks like we have an x approaching c. So c is negative 3 over 2 of x minus negative 3 over 2. So that's x minus c. This is f of c. This is f of x. So the function that we're trying to find the derivative of, f of x, is equal to 3 times cotangent of pi x over 2 squared plus 4x, and as we said, the c value where we want to find the derivative is negative 3 over 2. So I'm going to begin by finding the derivative of f of x. So f prime, using the chain rule, taking our time. So we're going to start with the power. So 2 times 3 is 6. Leave the inside alone. So we have cotangent of pi x over 2 to the first power. The derivative, we're going to go to cotangent next, is negative cosecant squared of the angle pi x over 2 times the derivative of the angle, which is pi over 2, and I'm sorry I don't have enough room, and that's going to be plus 4, because the derivative of 4x is 4. All right, now I'm going to evaluate that at c equal to negative 3 over 2. So I'm going to go ahead and substitute. I'm going to pull this out over to the side and do the substitution of negative 3 over 2 into pi x over 2 to see what I get. So if I have, now I'm over here on the left-hand side, pi over 2, I'm substituting the x value of negative 3 over 2. That's my x. So when I multiply that, I will get negative 3 pi over 4. So every time I have to substitute negative 3 over 2 into that expression, it's negative 3 pi over 4. So then I have, I'll start over here, f prime of negative 3 over 2 is 6 times the cotangent. Remember I said if I substitute negative 3 over 2 into that, I get negative 3 pi over 4, and that's to the first power. And then I'm going to substitute, I'm going to change this next expression to make it easier for myself to do negative, actually, what do I want to do there? Let's be careful. Let's be really careful. What would be better for your math eyes? I think I'm going to make that, I may be making this more complicated than necessary, but I just want to get the order of operations correct here on this next term. So it's the opposite of cosecant of negative 3 pi over 4 squared times pi over 2 plus 4. Okay, so the order of operations is going to be a big deal there. Now over here on the left-hand side, I'm going to come back to trig, and negative 3 pi over 4 is in the third quadrant. And in the third quadrant, the cosines are negative and the sines are negative. So I want to remember that when I'm evaluating this. All right, so let's start by evaluating the cotangent of negative 3 pi over 4. Cotangent of negative 3 pi over 4. Since we are in the third third quadrant, and we have the pi over 4 family, the cosine is negative root, come on, Jernigan, you can do this, negative root 2 over 2, negative root 2 over 2. Those are our values for the pi over 4 family. So the cotangent of negative 3 pi over 4 is 1. So that's just going to turn into 6 times 1. So that was pretty easy. Now we're going to multiply that by, let's play with cosecant. So now when we do cosecant, we know that cosecant is 1, I'll do that right here, 1 over sine of negative 3 pi over 4, and we're going to square that quantity. So the sine of negative 3 pi over 4 is going to be negative root 2 over 2. That's going to get squared. And 1 divided by negative root 2 over 2 is negative 2 multiplied by the reciprocal over root 2. That gets squared. And that's going to become 4 positive over 2, which is 2. And then we're going to do the opposite of that. So that's going to be times negative 2. That's going to get multiplied by the pi over 2. And then we're going to add the 4. These 2's divide out. That gives me negative 6 pi plus 4. So that was a doozy because you had this order of operations going on in there. You had to square first and then take the opposite, play with all that trick. So watch it again, practice it yourself, make sure you got it. To handle this on this particular test, but I'm going to go ahead and do it for subsequent years. In this case, I have a variable base raised to a variable power. So it's not exponential, it's not logarithmic, it's a variable base to a variable power, which requires log differentiation. So I'm going to do this over here. I'm going to begin in number 11 by taking the ln of both sides. So I have the ln of y on the right-hand side, left-hand side, and on the right-hand side I have the ln of that big quantity, 3x squared minus 7 raised to the 3x squared minus 7. And then I'm going to use a log property, so nothing happens with calculus. I'm going to bring that power of 3x squared minus 7 to the front, multiplied by ln of 3x squared minus 7. There's my log property. So step 1 and step 2, all algebra. Now I'm going to go to calculus, and the derivative of ln of y is y prime over y. On the right-hand side, I have a product. So I'm going to have the first function, 3x squared minus 7, times the derivative of the second. So that's a u prime over u. So u is equal to 3x squared minus 7. U prime is 6x over 3x squared minus 7, plus the second function, which is ln of 3x squared minus 7, times the derivative of the first. And the first is, the derivative of that is 6x. Cleaning that up a little bit before, let's see, can I clean? Yeah, I can do a little bit of cleaning. So I have y prime over y is equal to, I can divide the 3x squared and the 3x squared out, which leaves me, give me a second here, which leaves me with 6x in the numerator plus 6x ln of 3x squared minus 7. I could factor out the 6x, but I don't have to. So y prime, I'm going to multiply both sides by y, so that's 6x plus 6x times 3x squared minus 7, multiplied by y, and the original y was 3x squared minus 7, raised to the 3x squared minus 7. And you really don't need to do anything. You don't need to try to distribute or anything like that. So this is the first part of test 4 review.